Okay, so we finally built up now to do an example of what happens when a is not equal to 1. That's why we're going to be solving this quadratic equation by completing the square when a is not equal to 1. So that means we will need to implement step number 1. Finally, we always skip it. This time we're going to have to do something with it now. Okay, so let's solve this again. And by using the same steps that we've been doing this whole time, we're just going to implement step 1. But once you do step 1, then it's all the same as the other examples here, okay? Okay, so let's write the squared term as a equals 1. So that means our a term right here has to be a 1. Okay, well, obviously this a is not a 1. Okay, so you're like, well, dude, I mean, what are we gonna just like erase it and then make it a 1? Well, you can't do that because now it's a different problem. So we have to think, how do we mathematically make that a 1 but yet be the same equation? It's kind of like what the riddle is right there. How do you make a 3 at 1 but make it the same problem? Let me think about that. Well, what if we divide everything by 3? Right? If a mathematical equation means if I divide one side by 3 and if I divide the right side by 3, then it's still equal. They're still equivalent. So if I divide everything by 3, then that means my equation is still going to be equivalent. Or in other words, it's still the same problem. And that's the whole goal here. We can't change the problem. We got to keep it to be the same problem there. So 3 divided by 3 is x squared. 6 divided by 3 is our 2x. And then that gives us negative 2/3 equals 0. Oh, write the square term as a equals 1. And what do you know? Look, we have a equals 1. Bing! So that's all it really is in step 1 is basically just divide whatever your leading coefficient is. If it's not 1, then divide everything by that number, and now you complete step 1. Okay, so hopefully we can go through the next steps quickly here now because we've done a lot of these. Write the term so it looks like this. All right, so leave the x squared term, leave the 2x there, but move this 2/3 over here. So I'm going to go ahead and add the 2/3 to both sides. So get x squared plus 2x minus, not paying attention here. So that's going to be equal to 2/3, right? So now it looks like this. X squared and bx are on one side, and the c term is on the right. Bing! Step 3, divide b in half and square it. This one's actually not going to be a fraction. That's cool, but that's a fraction. Oh, well. 2 divided by 2 is 1, and then I square the 1, and I get 1. This right here is our special number, right? So 1 is our special number. So now, bing! Let's add the special number to both sides. X squared plus 2x plus 1, and then 2/3 plus 1. All right. So I'll just highlight what we just did right now. We just added 1 to both sides of our equation. See, this was what we had before, and then we did step 4, which said add that special number to both sides. Cool. And that's step number 4. Step 5, factor the left side. Cool shortcut, right? You just divide the middle number by 2. So x plus 1 squared. If I take 2 and divide it by 2, I get 1, right? And then it says simplify the right side. So let's go ahead and get a common denominator here. Right? Remember, you can put any number over 1, and the common denominator here is 3. So multiply top and bottom by 3. So 2 plus 3 is 5, and then we have a common denominator of 3. Bing! And last but not least, solve for x. Cool beans. So I'm talking about. So we'll take the square root of both sides. The radical crosses out with the square. So I just have x plus 1 equals plus or minus. See, I can't take radical 5 and I can't take the radical 3, so I'm going to still leave it as radical 5 over 3. In the previous 2 examples, I was able to actually take the square root of either, well, actually just the denominator. In this case, I can't take the radical of either one. Last step, let's just go ahead and subtract 1. And it looks like we be done. Negative 1 plus or minus the square root of 5/3. And I think that's going to do it for completing the square. Awesome.